Hello. Hello and welcome to this video. If you have watched my last video, then you know that I have decided to talk about chapter 4, 5, 6, and 7. But then I thought that 4, 5, 6, 7 we will actually learn practically, and a lot of it I have shown already. So instead of doing chapter 4, 5, 6, 7 and going through those, it is best if we can skip those and straight up go through chapter 9. So this video will be purely a read through because most of stuff which we are going to study is going to be very basic. But from the next video onwards, we will have some practical examples also. So without further delay, let's go ahead and read what chapter 9 holds for us. So it says PostgreSQL provides a large number of functions and operators for the built-in data types. This chapter describes most of them, although additional special purpose functions appear in relevant sections of the manual. Users can also define their own functions and operators as described in part 5. The psql command \df and \do can be used to list all available functions and operators respectively. The notation used through this chapter to describe the argument and result in type of a function or operator is like this. Repeat text comma integer the text, which says that function repeat takes one text and one integer argument and returns a result of type text. The right arrow is also used to indicate the results of the example. For example, repeat pg comma 4 gives you quadruple of pg. If you are concerned about portability, then note that most of the function and operator described in this chapter, with the exception of most trivial arithmetic and comparison operators and some explicitly marked functions, are not specified by the SQL standard. Some of this extended functionality is present in other SQL database management systems, and in many cases, this functionality is compatible and consistent between the various implementations. So first, we are going to look at and or. So Boolean of two ands would be a Boolean, or of two Booleans would be a Boolean, not of a Boolean is a Boolean. And I expect that you know the logic gate of and or. So true and true will make true, and in case of or, it will be true. True and false will make and false, and or true. True and null will make and get null, and or get true. False and false will make and false, and or also false. False and null will make and result false, while false and null will make or result null. Null and null will give null for AND gate as well as for OR gate. The NOT works differently. True will become false, false will become true, null will remain null. So the other than what we learn in the Boolean algebra, the occurrence of null is the extra thing which we have to learn. Okay. So make sure that you remember this table. Otherwise, it will be a problem and nulls will come. Okay. So pretty basic stuff. The operators and or are commutative. That is, you can switch left and right operands without affecting the result. However, it is not guaranteed that the left operand is evaluated before the right operand. Comparison functions and operators. So less than, greater than, less than equal to, greater than equal to, equal, not equal. So both not equal symbols we have used. This not equal basically means that left hand side is either less than or greater than, but not equal. Essentially, it is either less than or greater than, but not equal. And all these operators, comparison operators, result in booleans. Less than greater than is the standard SQL notation for not equal. Exclamation mark is equal to is an alias, which is converted to less than greater than at a very early stage of parsing. Hence, it is not possible to implement exclamation mark is equal to less than greater than operators that do different things. These comparison operators are available for all built-in types that have a natural ordering, including numeric, string, and date types. In addition, Arrays, composite types, and ranges can be compared if their component data type are comparable. It is usually possible to compare values of related data types as well. For example, integer greater than big int will work. Some cases of this sort are implemented directly by cross-type comparison operators, but if no such operator is available, the parser will coerce the less general type to the more general type and apply the latter's comparison operator. As shown above, all comparison operators are binary operators that return values of type Boolean. Thus, expressions like 1 less than 2 less than 3 are not valid because there is no less than operator to compare a Boolean value with 3. Use the between predicates shown below to perform range test. So we have comparison predicates, data type, between data type and data type result in Boolean. The example is 2 between 1 and 3 will be true. 2 between 3 and 1 will be false. Now, inclusive of range endpoint. So we'll see why this is the case, okay? Data type not between this and this, so 2 not between 1 and 3 is false. And data type between symmetric data type and data type. Between after sorting the two endpoint values, 2 between symmetric 3 and 1, 2 not between symmetric 3 and 1. Then is distinct from data type is there. 1 is distinct from null is true. Null is distinct from null is false. Data type is not distinct. 1 is not distinct from null is false. Null is not distinct from null is true. Data type is null, gives a Boolean. Text whether a value is null, 1.5 is null, is false. Is not null, null is not null, is true. Here null is a string. Database is null, text whether value is null. It is a non-standard syntax, not null, non-standard syntax. Boolean is true, text whether Boolean expression is true. True is true, null conjunction Boolean is true. And so there are other examples for is not true, is false, and is not false. Is unknown and is not unknown. So these are also something you can take care of, but is unknown and is not unknown will be very rare cases where you need that. The between predicate simplifies range test. A between x and y, a greater than equal to x and a less than equal to y. Notice that between treats the endpoint values as included in the range. Between symmetric is like between except there is no requirement that the argument to the left of and be less than or equal to the argument on the right. If it is not, the two arguments automatically swap so that a non-empty range is always implied. So now you see why this is false and this is true. So 2 should be greater than equal to 3, which is true. But 2 is less than 1. So that's why it is coming as false, but this is coming as true. Okay. So where were we? Yeah. The various variants of between are implemented in terms of ordinary comparison operators and therefore will work for any data types that can be compared. Let me expand this. Okay. The use of and in the between syntax creates an ambiguity with the use of and as a logical operator. To resolve this, only a limited set of expression types are allowed as a second argument of a between clause. If you need to write a more complex sub-expression in between, write parentheses around the sub-expression. Ordinary comparison functions yield null, specifying unknown, not true or false, when either input is null. For example, 7 is equal to null yields null, as does 7 not equal to null. When this behavior is not suitable, use the is not distinct from predicate. A is distinct from B and B is not distinct from B. For non-null inputs is distinct from is same as the less than greater than operator. However, if both inputs are null, it returns false. And if only one input is null, it returns true. Similarly, it's not distinct from is identical to is equal to for non-null inputs. but it returns true when both inputs are null and false when only one input is null. Thus, these predicates effectively as though null were a normal data value rather than unknown. To check whether a value is or is not null, use the predicate expression is null or expression is not null, or the equivalent but non-standard predicate is null and not null. Do not write expression is equal to null because null is not equal to null. The null value represents an unknown value and it's not known whether two unknown values are equal. Some applications might expect that expression is equal to null. It is true if expression evaluates the null value. It is highly recommended that these applications be modified to comply with the SQL standard. However, if that cannot be done, the transform underscore null equals configuration variable is equal. If it is enabled, PostgreSQL will convert x is equal to null clauses to x is null. If the expression is row valued, then is null is true when the row expression itself is null or when all the rows fields are null. While is not null is true when row expression itself is non-null and all the rows fields are non-null. Because of this behavior, is null and is not null do not always return inverse results for row valid expressions. In particular, a row value expression that contains both null and non-null fields will return false for both tests. For example, we have a row here 1, 2.5. This is a test, and 1, 3 not the same, so both are not equal. Row table dot star is null from table. It detects all null rows. Row table dot star is not null from table. Detect all non-null rows. Select not row table dot star is not null from table. Detect at least one null in rows. In some cases, it may be preferable to write row is distinct from null or row is not distinct from null, which will simply check whether overall row value is null without any additional tests on the row fields. Boolean values can also be tested using predicates. Is true, is not true, is false, is not false, and so on. These will always return true or false. Never a null value, even when the operand is null. A null input is treated as a logical value unknown. Notice that is unknown and is not unknown are effectively the same as is null or is not null respectively, except that the input expression must be of Boolean type. So we have comparison function num nulls and num nulls, which will count the non-nulls and nulls. So in this case, count of non-nulls is 2. And in this case, count of nulls is 1. So you can give as many arguments of any type as you want. Now I will stop here because the mathematical function on operators is a big one. It is 8 pages. So we will cover this in tomorrow's video. So the basic stuff is quite simple if you follow the read through along, and it is not complicated. You have to be careful about this between stuff, and it's better if you use symmetric one. Okay, try to avoid the between comparison predicate. It is confusing basically because you see this one is true, but this one is false for the reasons I have explained in the video. So in tomorrow's video, we will cover mathematical functions and operators, and I'll try to finish this entire thing in one video. So I hope that you are enjoying this video, and in the next video, we will also see some examples of mathematical functions and operators. This one was pretty simple, so I have not shown any practical examples. But for mathematical functions and operators, I'll ensure to have some examples. So I hope that you are finding this read through useful and informative, because of course we are going to the manual, so it is as exhaustive as it can be. So I thank you for watching the video, and I'll see you tomorrow in the next video. Till then, I'll say bye to you, and let's meet tomorrow in another video. Thank you. Bye.